Let's start with the chapter hyperbola. The standard equation for a hyperbola of the hyperbola is x square upon a square minus y square upon b square is equals to 1, where b square is equals to a square e square minus 1. Now, it is drawn like this. Let's say this is our y-axis, this is our x-axis, this is the hyperbola. Okay, these points are vertices, these points are vertex. You can write as vertex. This is a comma 0, this is minus a comma 0. Then you have these points as focus. These 2 points, focus plus minus a comma 0. Okay, E is the eccentricity, and in hyperbola eccentricity is greater than 1. This is the main point of hyperbola. Okay, if it is less than 1, then it will be an ellipse, and if it is equals to 1, then it will be a parabola. So that's why. Now this is the origin 0 comma 0. Fine. Now we'll see the main points about hyperbola. For this hyperbola, x square is upon a square minus y square upon b square is equals to 1. The focus, as we have seen, S is plus minus a comma 0. Okay, and this is the formula to calculate E or B or A. Okay, if two of them are given. Now directrix will be given by x is equals to plus minus a by e. Okay, these are the directrix. There are two directrix, x is equals to minus a by e and x is equals to plus a by e. As e is greater than 1, so this point will be from minus a comma 0, this will be shorter, and from plus a comma 0, this will be shorter. So that's why directrix is plus minus a by e. Vertices, as you have seen, plus minus a comma 0, these are the vertices. Now the latus rectum, which is the important point, latus rectum, this is given by 2b square by a for this parabola, for this hyperbola. Okay, or you can write it as 2a e square minus 1. Okay, because b square is a square e square minus 1, that's why a will get cancelled and length of parabola small l is equals to 2b square by a. Now we're going to see some more formulas. Second one, conjugate hyperbola. Conjugate hyperbola will be minus x square by a square upon y square by plus y square by b square is equals to 1. Okay, so conjugate hyperbola is minus x square by a square plus y square by b square is equals to 1, or you can write x square by a square minus y square by b square is equals to minus 1. Fine. So this is the conjugate hyperbola for this hyperbola. Okay, conjugate hyperbola. Now auxiliary circle for this hyperbola, I'm going to make it with red, with orange. Auxiliary circle. This is the auxiliary circle for. Okay, so this auxiliary circle, let's make it completely. Okay, this auxiliary circle, the equation for this auxiliary circle, third one, auxiliary circle, the equation will be x square plus y square is equals to a square, because the 2 points are minus a comma 0 and plus a comma 0. So it is like the diameter. So the radius will be a by 2, and that's why x square plus y square is equals to a square. Okay, these 2 points satisfy this equation. Fourth one, parametric representation of a hyperbola. In this we take 2 points like x is equals to a sec theta, which also satisfies this equation. Y is equals to b tan theta. Okay, why is that? Because let's take this and put it in the equation, original equation, this equation. not this equation, plus 1 is the original equation. So x square by a square, that will be a square sec square theta by a square minus b square tan square theta by b square is equals to 1. Is it true? Yeah. Sec square theta minus tan square theta is equals to 1. This is the trigonometric equation which is true. Equality. So these two can act as parametric. This can be parametric variables. Okay. Parameters. We can take to solve the questions, different questions. For this one, you will take x is equals to a tan theta and y is equals to b sec theta, because minus 1 is in the right hand side. So that's why we will take x and y as interchanged. Now, position of a point P with respect to a hyperbola, that will be position of a point P with respect to hyperbola S1 is equals to x square by a square minus y square by b square minus 1 is greater than 0, equals to 0, less than 0. For these three, accordingly. Okay, so if it is greater than 0, then it will lie inside. If it is equals to 0, then it will lie on the hyperbola. If it is less than 0, then it will imply outside. Okay, outside the curve, the hyperbola. So you have to calculate this S1, the value of this thing, x square by a square minus y square by b square minus 1. This thing, if it is greater than 0, then it will be inside the hyperbola. If it is equals to 0, then it will be on the hyperbola. If it is less than 0, then it will be outside the hyperbola. Now, this is the position of a point. If you have any point, like you have to, this is your hyperbola, and you have to see that a comma b, what is the position of a comma b with respect to this hyperbola. Then you will just calculate, you will just put this a here, b here, and see the thing that it lies outside or inside or on the curve. Okay. The next point is tangents. Equation of tangents for this hyperbola. First, slope form. Slope form is y is equals to mx plus minus root of a square m square minus b square. Second, point form, that will be at the point, of course, x1 comma y1. You will be given the point, then you have to find the equation. That will be x1 upon a square minus y1 upon b square. Okay, we have made the x square as x into x and one of the point is x1. Okay, similarly y into y for y square and one of the point is y, and that's how the equation came, is equals to 1. Fine. So this is the thing. If you have given a point, then you will apply this form, point form. Third equation, it will be parametric form. Parametric form for tangent, it will be x sec theta, as we were given the point, x a sec theta upon a. Okay, one of the a sec theta and a square, this will cancel out, so you will left with a sec theta upon a. Similarly, y tan theta upon b, right? The point here x1 y1 will be in the parametric form a sec theta and b tan theta is equals to 1. Fine. So this is the equation. This is the parametric form of the tangent of a hyperbola. Now we'll see the normals of hyperbola. Normals. Equation of normals. At the point x1 comma y1 is, normals at the point x1 comma y1 are a square x1 upon x1, a square x upon x1 plus b square y upon y1 is equals to a square plus b square, or you can write is equals to a square e square. Fine. Now this is the equation for these. This and this are equal. Okay, so this is the equation of a normal at the point. If you are given a point x1 comma y1, okay, at the hyperbola, then you'll find the equation of normal as by this equation. Okay, by this formula. At the point, at a parametric point, let's say a sec theta comma b tan theta, that will be ax upon sec theta plus by upon tan theta is equals to, of course, the same thing, a square plus b square or a square e square. Fine. Now the equation of normals in terms of slope, the third and the most important equation of normal in terms of slope m are y equals to mx plus minus a square plus b square into m. It is plus minus, keep that in mind, root of a square minus b square m. And this is used frequently in the questions because sometimes the questions are just as that the slope of the normal is given to you. What is the equation? Okay, so this will be the equation for normal. A and B will be given to you. So just put the values of a and b in the equation and you'll get the answer. Now I'll see the asymptotes for the hyperbola. Equation of asymptotes: x by a plus y by b is equals to 0 and x by a minus y by b is equals to 0. These two are the, or you can write it as asymptote, and you can write it as x square by a square minus y square by b square. Just by multiplying both of them you can get this. Okay, so this is the most important equation, or you can say it is the pair of asymptotes. Fine, pair of asymptotes. Now pole and polar, we will see the pole and polar of a hyperbola. Pole and polar. The pole of a given line, pole of a given line Lx plus My plus N is equals to 0 with respect to the hyperbola x square by a square minus y square by b square is equals to 1 is, it's a point, so it will be a open bracket minus a square L by N comma minus b square m by n. Okay, this is the point which is the pole for a given line Lx. There you will be just asked that the what is the pole for this given line, like 2x plus 3y plus 5 is equals to 0 for the hyperbola x square by 5 minus y square by 2 is equals to 1. So you have the a value root 5, b value root 2, okay, b value this root 2, root 5, and you have the equation L, M and N, values for L, M and N. So you'll just put them here and you'll get the point, which is the pole of the given line. Now, polar. For polar, we will see that any tangent is the polar of P(x1, y1). I am sorry. Any tangent is the polar of x1, y1 passes through Q, which is, let's say, x2, y2. Then the polar of Q will pass through P and such points are called conjugate points. So the thing is that any tangent is the polar of any point P if that for this tangent, let's say this is the curve, this is the tangent at this point. Now if for P, if this tangent passes through Q, then the tangent from Q will also pass through P. So that's why these are called the conjugate points. Now we'll see rectangular hyperbola. The properties of rectangular hyperbola. It's also called equilateral hyperbola. This is also the favorite topic from hyperbola. This is xy is equals to c square. This is the hyperbola. Okay, you can see the equation. Like I will take a graph of xy is equals to 1. So this is and this thing. This is the graph for xy is equals to 1. At this point, this is 1 comma 1. This point, it is minus 1 comma. Of course, this is 1 comma 1. Okay, this point is 1 comma 1, and this point is minus 1 comma minus 1. So it lies on this parabola, this hyperbola. This is called the rectangular hyperbola. For any c square, the eccentricity is root 2 always. Vertices, these vertices will be plus minus c comma plus minus c. Okay, just like I said, 1 and minus 1 comma minus 1 and 1 comma 1. Just like that, plus minus c comma plus minus c. The focus, this is the vertices. The focus will be plus minus root 2c comma plus minus root 2c. Directrix, that will be x plus y is equals to plus minus root 2c. Why is that? Because directrix will be like this time, right? Directrix is like this for every hyperbola. So if this is the tilted hyperbola, then directrix will be tilted. So that's why the line will be x plus y with a slope of minus 1, right? Plus minus root 2c. The focus is plus minus root 2c. Now we'll see the lattice rectum and all the other formulas. Lattice rectum, the length of lattice rectum is 2 root 2c for this xy is equals to c square hyperbola. And parametric equation, for this hyperbola, that will be x is equals to ct and y is equals to c by t. When you multiply these two, you will get xy is equals to c square, right? So these are the parametric equations. This is the parametric equations for hyperbola. Of course, t is not equals to 0 because t cannot be 0 in here. So t, or you can say t belongs to r minus 0 set, right? Now equation of tangent for this hyperbola, equation of tangent at, let's say, x1 comma y1 is x by x1 plus y by y1 is equals to 2. Okay, remember this, x by x1 upon y plus y by y1 is equals to 2 at, now this is at x1 comma y1, but at p comma at pt, which is the parametric form, at pt it will be, or at ct comma c by d, x by t plus yt is equals to 2c. This will be the equation at ct comma c by t, right? So this is the parametric one. Now we are going to read the equation of normal. The equation of normal for this hyperbola xy is equals to c square at the ct comma c by t, which is also called pt, is xt cube minus yt is equals to c t to the power 4 minus 1. This is the equation for hyperbola. Now, chord with a given point, given middle point. These are the questions which are directly asked, so I am not giving any examples for this because they'll just ask the equation of normal at this point. Now you have to use this formula only. Okay, so middle point as h comma k, let's say, is kx plus hy is equals to 2hk. Fine. So this is the equation of a chord with the given middle point. You will be given this middle point, and you will be given the parabola. So you have to just find the equation with chord of the equation of chord with this given middle point. Okay. Now, one important point which I am going to write with pink is for in the hyperbola chapter is that if PM be drawn perpendiculars to the conjugate axis from a point P on the hyperbola and the tangent at P meets the conjugate axis in T, then OM into OT is equals to minus B square, actually, where O is the origin. Okay, the diagram for this will be like, we will take the simplest example. This is the origin here, and if PM be drawn perpendiculars to the conjugate axis. Now P is any point on the hyperbola and this is the perpendicular. So P, okay, so this is OM and the tangent at P meets the conjugate axis. Now let's say this is the tangent at P. Now this is T, then OM into OT is equals to minus B square. This distance into this distance will be minus B square. This is a property which you know, the JEE questions has asked this property directly, and you can apply this. That they have asked that what is the distance between, what is this distance and this distance. So you can just find the minus B square, okay, and you can apply this property and you will get the answer. Okay, here we complete our hyperbola.